In this video, I'll show an example of finding the points of inflection and regions of concavity for a function. So suppose the function we have is f of x equals x to the fourth minus 6x squared. So first thing we'll have to do to find points of inflection and regions of concavity is take two derivatives. So the first derivative would be 4x cubed minus 12x. That's the first derivative. Now the second derivative is 12x squared minus 12. So set this equal to 0 to find a point of inflection. 12x squared equals 12, x squared equals 1, x equals plus or minus 1. And so it means that the function has points of inflection at plus or minus 1. Well, now we can do a number line for the second derivative. Here's negative 1, here's positive 1. And of course, what this is, if you think about just the graph of this function, 12x squared minus 12, that's an upward-facing parabola. Upward-facing parabola that is pulled a little bit below the axis in the middle. So the middle part would be negative, and the outer parts would be positive. And so what this tells us, if the second derivative is positive in those outer regions and negative in the inner regions, it means that the function is concave up from negative infinity to negative 1, and also from 1 to infinity, and it is concave down from negative 1 to 1. And in fact, if you graph the function, and this is a somewhat compressed graph of the function goes something like this, and it has this large region where it is concave up, then this very small region in the middle where it's bold upside down and it's concave down, and then it goes back to being concave up on the other side. And again, at 1 and negative 1, we have those magical points of inflection, the points where the concavity changes.